Here I am going to discuss an extremely interesting question that was asked in our class. So this is the question. We were discussing about the compensating coil of an wattmeter. Let me just recall it very briefly. So we saw that if I connect the wattmeter across a load like this, with this being the current coil and this being the pressure coil, then we saw that here the voltage that the pressure coil measures is the voltage across the load plus the voltage across the current coil, and therefore the reading will be slightly erroneous. On the other hand, if we connect it like this, where I have the voltage coil or the pressure coil measuring exactly the voltage across the load. In this case, the current coil is measuring a current which is the sum of the current through the load and through the pressure coil. So again, the estimated or measured load power will be slightly wrong. Then we came to a compensating scheme where we had this current coil connected in series to the load, and then we started the pressure coil from here, and initially the pressure coil runs along the current coil in an opposite direction, and its turns are also in a direction opposite to the turns of the current coil, and then this current passes through the pressure coil and goes to the other side. So this is the pressure coil, and here the green is the compensating coil, and the black one is the usual current coil. And we said that in this case, the current that passes through the current coil is the sum of this load current and this let me call it IV for voltage coil current. So the current through the current coil is sum of IL plus IV. However, the flux flux generated by this coil is basically the flux generated by the forward current, which is phi L plus phi V, that is the flux generated by this current and this current respectively, and then minus flux generated by the reverse current, which is phi V, that is this IV amount of current comes back in the opposite direction. So this two cancels, and the flux generated by this coil is directly proportional to the current of the load or load current. Now the interesting and very interesting question here is that these two coils, the compensating coil and the current coil, they are heavily mutually linked in a sense of magnetic linkage, because they are just wound one on top of the other, so they have their flux being mutually linked. Therefore, the current in the current coil will also generate a voltage in this compensating coil, and therefore the voltage across this pressure coil plus compensating coil is a sum of this load voltage plus or minus, depending on the direction, the mutually induced voltage in this coil. And thus, in this case, the pressure coil is no longer measuring the voltage across the load, but is measuring the load voltage plus or minus this mutually induced voltage. And therefore, the obvious question is that what is the utility of this compensating coil then? We just wanted to correct for this small amount of error due to the fact that this pressure coil also carries some amount of current which passes through the current coil, and for that small amount of error which we wanted to compensate for, we have generated another small amount of error, small or large, we have to verify. So what is the use of this? This scheme is of no use. So this was the question that was raised in our class, and we thank our friends for asking this very interesting question. And now I'm going to discuss the solution of this question. Okay. So before that, let's assume we are measuring DC power. That means the current, voltage, power, everything is DC. And in that case, there is no problem. Why? I mean, this is very obvious. If the current flowing through the current coil is DC, then there is no fluctuating flux which can generate a mutually induced voltage in the compensating coil. So for DC, there is no problem absolutely. Now let's come to AC. In this case, the current flowing through the current coil can generate a mutually induced voltage in the pressure coil, and so the problem can happen. However, I'm going to show that even in this case there won't be any problem. Why? Because the voltage across pressure coil is equal to the voltage across load voltage plus or minus the mutually generated voltage. Let me call it Vm. So Vm is the voltage generated due to flux linkage between this current coil and this compensating coil. Now note that this voltage Vm, okay, so now before that, therefore the current in the pressure coil, so IPC, current pressure coil, will be this divided by the RPC, resistance of the pressure coil. And then the torque developed, average torque developed, will be proportional to the current, let me call it flux of current coil, which is proportional to the load current times, so this is the torque, this times the flux due to pressure coil, and this is further equal to this times IPC with some constant, the proportionality constant between flux, pressure coil flux and pressure coil current. So this is further equal to 5, up to some scaling constant. Okay, let me rather put proportionality sign instead of equality. So 5 cc times this VL plus or minus Vm, and then this is again equal to 5 cc VL plus minus 5 cc Vm, and this is proportional to the load power. It's absolutely acceptable, and this is the amount of error in the measured power. But now I am going to argue that this term is equal to 0, and here is my argument. The argument is that these two this flux and this voltage, they are out of phase by 90 degree. So let me prove that. So if this is Cc phi current coil flux, let this be the phi Cc, and we saw that phi Cc is proportional to IL, the load current, because the pressure coil current which goes in forward direction and then comes back, their fluxes cancel each other, nullify each other. So current coil flux phi Cc is proportional to IL. Okay, and then the Vm, which is the voltage due to the variation of flux in this coil, so that will be, so Vm will be, so Vm should be equal to ddt of phi Cc. So this implies that Vm will be 90 degree lagging the flux of the current coil. So Vm will be here, right? So I mean, therefore it is proved that, I mean, these two are out of phase, and therefore the average torque generated by this component will be 0. So that justifies that this compensating coil will not create any problem due to the mutually induced EMF in this compensating coil, and that justifies the use of this compensating coil. It's a very interesting question.